Hey guys, hope you guys are doing well. Like I told my other math class, I probably wasn't going to come to school today just because I'm not feeling well. But what I'm going to do is I'm going to make videos for chapter one, so you can watch this at home, and then when we give in class, we're going to do the work. And the reason why is because it's a lot of studies showing that when you do the content at home and then come in class and do the work, it just allows for a lot more time being spent on the work and getting a lot more help where you actually need it, instead of me talking for half an hour and then only having like 10, 15 minutes of actual work. So we're going to chapter one, which is linear relations, and we're going to start with 1D and then go to, I think it's 1G. So 1D is called solving linear equations. And basically, when we're solving for linear equations, what we want to do is we want to solve for x. And we use something called inverse operations to help us isolate x, or get x by itself and solve. Inverse operation sounds pretty funky, but it's just doing the opposite of what's on the screen. So let's look at this example here. So I have x plus 2 is equal to 4. If I'm solving this linear equation, what I want to do is I want to get x by itself. And we can see here we have x plus 2 is equal to 4. So I've got that plus 2 with the x. So all I'm going to do is I'm going to do the opposite of plus 2 to get the 2 from this side to this side here. So opposite of plus 2 is minus 2. So I'm going to do minus 2 from this side. Now what I'm going to do to one side, I've always got to do to the other. So I'm going to do minus 2 on this side as well. Now 2 minus 2 is 0, so this basically cancels out. So I'm left with x on this side and then 4 minus 2 on the right hand side, which is 2. So that's how I solve my linear equation. So that's basically what we're going to be doing. It's stuff that you've done before, but now we're taking some added complexities onto it as well. But yeah, so let's just get into some work examples because that's the best way to do it. I'm going to walk you through my thought process. Yeah, so this example say solve the following equations, then check your solution by using substitution. So what that means is we're going to solve for x like we just did before. And just like here, how we got x is equal to 2, we're now going to substitute 2 and see if it still makes sense. And you'll see what I mean. So for a, we have 4x plus 5 is equal to 17. So we can see here we have 4 times x, right? And then we have a plus 5 is equal to 17. We're going to get rid of that plus 5 first, just so we're left with that 4x. Opposite of plus 5 is minus 5. So I'm going to do minus 5 on this side. And when I do to one side, I've got to do to the other. So I do minus 5 on this side. So these two cancel out. So I'm left with 4x is equal to 17 minus 5, which is 12. I'm now left with 4x is equal to 12. Now 4x is the same thing as saying 4 times x. 3x is the same thing as saying 3 times x. Whenever there's a number attached to the x, that's a times, right? So what's the opposite of times by 4? It's divided by 4. So I'm going to do divided by 4 on this side. I want to do to one side, I've got to do the other again. Divided by 4 on this side. So I'm going to be left with x is equal to 3. So I've solved for x. And now what we've got to do is we've got to use this answer here and substitute it back. So this is what it looks like. So now I'm going to use purple. So we have 4. I'm just rewriting this one here. We have 4. Now we know that x is equal to 3, so I'm going to put 3 in. Plus 5 is equal to 17. Now if we've done it right, it should make sense. Let's quickly work it out. 4 times 3 is 12, plus 5 is equal to 17. Thus us checking our answer through substitution. So if it makes sense, like if it adds up correctly, if it multiplies correctly and gives it the right answer, that means we've done it right. So that's our first one. Now we have 3 bracket 2x plus 5, close brackets equal to 4x. So you can see that we have an x on this side, an x on this side, and then also the brackets. So we're going to do BODMAS, and the first thing we're going to do is expand our brackets. Now, if you remember from expanding brackets, what we do is we take the number outside the bracket, so the 3, and multiply it by the 2x, and also multiply it by the plus 5. It's really important that you keep that, this is plus 5, or you notice it's plus 5, because sometimes it might be minus 5, and you're going to times it by negative. But, so what I'm going to do is 3 times 2x. You can put it in your calculator if you want, but I know it's 6x. So that's that one there. And then 3 times plus 5, or 3 times positive 5 is 15. So I'm left with 15 is equal to 4x. Now, what I want to do is I want to get all my x's on one side and my whole numbers on the other. So what I'm going to do is I'm going to go ahead and minus 15 from this side. Let me go to red. I'm going to minus 15 from this side to get rid of it from there. And then I'll put minus 15 on this side here. So I'm going to be left with 6x is equal to 4x minus 15. Now, we still have our x here and an x here. So we're going to move our 4x to the other side. So this here is considered positive 4x. So all I'm going to do is I'm going to minus 4x from the right hand side. So minus 4x here. That's going to get rid of this one. And that's also going to minus 4x on this side here. Right, 6x minus 4x is 2x. And then I'm left with negative 15. And then we have 2 times x is equal to negative 15. Opposite of 2 times something is divided by 2. So I'm going to divide both by 2. Divided by 2, divided by 2. And I get a final answer of x is equal to negative 15 on 2. And that's my final answer. And then using substitution, you guys can do that on your own or just put in the calculator. And that's how I do that one. Right, next one. Now this is where it gets a bit trickier. So we have x plus 3 divided by 4 is equal to 2. So our first step is we want to get rid of this divided by 4, right? Because that's the biggest thing there. Because if we get rid of the divided by 4, then we're left with x plus 3, and it makes it easier for us to work with. So the opposite of divided by 4 is times by 4. So I'm going to times this side by 4. I'm also going to times this side by 4, because what I do to one side, I've got to do the other. So I get x plus 3 is equal to 2 times 4, which is 8. And now I'm left with x plus 3 is equal to 8. So I want to get rid of that plus 3, so I do the opposite. I'm going to go ahead and do minus 3 from this side and minus 3 from this side. And then I'm left with x is equal to 5. And I can go ahead and substitute it in if I wanted to. I'll let you guys do that. All right, and now, sorry, probably the trickiest one. We have this here. So this is where it might be a new concept to you guys. We're going to be using something called the lowest common denominator, and I'll explain that as well. So we have 4x minus 2 divided by 3 is equal to 3x minus 1 divided by 2. So you can see here, this is divided. So this part here is divided by 3, and this part here is divided by 2. So we can't get rid of it, right? We can't just times this one by 3, because then we're timesing this one by 3, and we're not getting rid of this denominator. So what we're going to do is we've got to do something called the lowest common denominator. So essentially what you've got to do is you've got to write down the multiples of 3 and 2. So I might do it like this. Maybe I'll do. So the multiples of 3 are 3, 6, 9, 12, 15. I'll stop there. And then I'm going to do the multiples of 2. 2, 4, 6, 8, 10, and I'll stop there. Now what you want to do is you want to see from the multiples any two of these numbers that are the same. So I can see here that 6, so I have 6 when I multiply 3 by 2, and I have 6 when I multiply 2 by 3. So our lowest common denominator is 6. So what that means is I want to get this denominator here to equal to 6 and this denominator here to equal to 6. Because when they're under the same denominator, I can just times it by that number and get rid of the fraction. So 3 times 2 is equal to 6. So what that means is I'm going to times this entire side by 2. And 2 times 3 is equal to 6. So that means I'm going to times this entire side by 3. So I'm going to go ahead and do that now. So 4x times 2 is 8x. Negative 2 times 2 is negative 4. 3 times 2 is equal to 6. And now I'm going to multiply the right hand side by 3. So I'll get 9x minus 3 over 6. And now because they're under the same denominator, I can go ahead and times it by 6. And now get rid of this denominator and this denominator, which makes it a lot easier for us to work with. So I'm going to go ahead and times both sides by 6 now. So times this entire thing by 6, times this entire thing by 6. And I'm left with 8x minus 4 is equal to 9x minus 3. And from here, it's the same thing I did before. I want to get all my x's on one side and all my numbers on the other side. So I'm going to start by getting this negative 4 to this side there. So the opposite of minus 4 or negative 4 is plus 4. So I'm going to plus 4 from this side. And when I do to one side, I've got to do to the other. So I plus 4 from this side as well. Now that leaves me with 8x is equal to 9x. Negative 3 plus 4 is positive 1. So plus 1. And now all I want to do is get my x's to the other side. So I have plus 9x on this side. So opposite of plus 9x is minus 9x. So minus 9x from this side and minus 9x from this side. So I'm going to be left with, I'm going to go down the page. Excuse me. 8x minus 9x is equal to negative 1x. Is equal to positive 1. Now, negative 1x times x, opposite of that is dividing by negative 1. So divide both sides by negative 1, and I get x is equal to negative 1. And this will be my answer. So just to recap, what I've done here is I have to get these two denominators to the same number. So I do something called the lowest common denominator, where I work out their multiples, see how many times it gets to that multiple. So 3 times 2 is equal to 6, and 2 times 3 is equal to 6. That's why I've multiplied it by these numbers here. And then I've gone ahead and just solved it like I would anything else. So times it by 6 to get rid of this fraction, times by 6 to get rid of this fraction, and then I've solved it like I have in the past. That's the hardest question you come up to. It takes a few steps, but once you guys do a few, it'll become a lot easier. Also, the interactive textbook that you guys have on Cambridge Go has worked examples or video examples, so you guys can go ahead and use that as well if you get stuck, and it'll walk you through the process. Hopefully that's okay for you guys. I'm sorry that it's a bit of a short, oh, not a short video, a bit of a long video, but rushed through it. I'm just not feeling too great, so I wanted to get through this pretty quickly. If there's anything you guys are stuck with, make sure you shoot me an email or just shoot me a Teams message, and I'll get back to you when I can. When I'm not sleeping. That's about it. I'm going to make videos for 1E, 1F, and 1G as well, and you guys are meant to watch them before we do, like before class. So for instance, for my 103 class, today you'll be continuing with 1D, and then on our next class we'll be starting with 1E. And for my 101 class, you guys are starting 1D, the next lesson will be for 1D, and then we're moving on to 1E. So watch those videos that I make before we come to class, that way in class you're just doing the work. Alright, easy. Have a good one guys, enjoy yourselves.